Are you struggling to get the cv.transform function to work with your points? You're not alone. Many users face this challenge when trying to apply affine transformations. Today, we're going to break it down and help you understand what's going wrong. I totally get how frustrating it can be when you're trying to manipulate points and you keep running into errors. It can feel like you're hitting a wall, especially when the documentation isn't clear. You're in the right place to find clarity. Let's dive into the specific question at hand. One user asked, "Why am I getting an error when using cv.transform with my NX2 matrix of points?" They shared their code and the error message they received. Sound familiar? Let's explore this together. So what's happening here? The error message indicates a mismatch between the number of channels in your source points and the columns in your affine matrix. This can be confusing, but we'll clarify what channels mean in this context. And stick around. By the end of this video, you'll not only understand the error, but also learn how to apply transformations correctly. Trust me, you won't want to miss this. To understand the issue with the cv.transform function, let's first clarify what the affine matrix M represents. The user should know that M is a two-dimensional array that defines how points are transformed in the X and Y coordinates. Next, the user needs to ensure that the shape of the source points matches the requirements of the cv.transform function. Specifically, the number of channels in the source points must equal the number of columns in the matrix M. The user should also note that the error message indicates a mismatch in the expected number of channels. This means that the source points should be formatted correctly before passing them to the cv.transform function. Finally, if the user wants to use cv.transform effectively, they should reshape their source points or adjust the affine matrix M accordingly. This will help avoid the error and achieve the desired transformation. Fun fact, the concept of affine transformations is used in everything from computer graphics to robotics. It's amazing how math can help us manipulate images and shapes. Now, let's look at the answers provided by other users. An alternative solution suggests that the last dimension of the source array must match the number of columns in the transformation matrix. The user explains that each element of the source array should have more than 2 dimensions for the transformation to work correctly. The user also demonstrates that as long as the last dimension is correct, other dimensions can vary. They provide examples of reshaping the source array to fit the requirements of the cv.transform function. Here's a pro tip. Always double-check the dimensions of your matrices before applying transformations. This simple step can save you a lot of headaches down the line. And there you have it. You should now have a clearer understanding of how to use cv.transform and avoid those pesky errors. If you found this video helpful, please subscribe for more tips and tricks on computer vision.